In this video, we're going to go over a fundamental skill in Trig, which is evaluating trig functions using special triangles and the unit circle. So one of the first things you learn about in Trig is this mnemonic device, SOHCAHTOA. And that just stands for sine being opposite over hypotenuse, cosine being adjacent over hypotenuse, and tangent being opposite over adjacent. So you can think of these sides coming from a right triangle, where the side opposite of the right angle, that's the hypotenuse. And we're going to label this angle theta, that's just the Greek letter theta, which we use as the variable to represent angles a lot of times. So if I wanted to take sine of that angle theta, that would just be opposite over hypotenuse in that order. But there's also three more reciprocal trig functions, cosecant, secant, and cotangent. And these are the reciprocals of the ones from above. So like cosecant is the reciprocal of sine, so that one would be hypotenuse over opposite. Secant is the reciprocal of cosine, so that would be hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so that would be adjacent over opposite. All right, so let's put that idea on hold for a second. And now let's take a look at reference triangles, or in the past you've probably heard of these called special triangles. So the first one we'll look at is a 45, 45, 90 triangle. So each of these two angles is 45 degrees. But now we're actually going to think of these as pi over 4 as well. So you're probably familiar with the side lengths being 1, 1, and the square root of 2. But we're going to use something called the unit circle a lot. And on the unit circle, it just means that the radius is 1. And so you can think of this right triangle here on the unit circle. So we actually want the hypotenuse to be 1. It's going to be more useful for us that way. So in order to make it 1, we'll just divide it by the square root of 2. But I can't just divide one side. If I'm going to scale the whole triangle down, I'd have to divide everything by the square root of 2. So that makes the other side length 1 over the square root of 2. And I don't like having a radical in the denominator, so we're going to do something called rationalizing the denominator. And in order to do that, we just multiply by what's down there. So square root of 2 over square root of 2. So the top we would get square root of 2, and on the bottom, if you took the square root of 2 and multiplied it by itself, it's like you're squaring it, so the square root cancels out, and we're just left with square root of 2 over 2. And so you get the same thing on the other side length as well. The other special triangle you're probably familiar with is a 30, 60, 90, or now that we're dealing with radians, pi over 6 and pi over 3. And most people label this triangle as 1, 2, and then square root of 3. And I remember that it goes in this order because if you take the square root of 3, it's about 1.7-ish, and that's less than 2, and the hypotenuse has to be the biggest side length. So anyways, it goes in that order. But remember, we want the hypotenuse to be 1 because we're dealing with the unit circle, where the radius is going to be like the hypotenuse. So in order to make that 1, we're just going to divide it by 2. 2 divided by 2 is 1. And again, we'll scale the entire triangle down, so we'll divide everything by 2. So this side will be the square root of 3 over 2, and this side will be 1/2. All right, so now let's take a look at taking the sine, cosine, and tangent of special angles using our special triangles. So if I was asked to take the sine of pi over 4, I would draw out this triangle with one of the angles being pi over 4. So remember, this is like our 45, 45, 90 triangle, and sine is opposite over hypotenuse. So that would be square root of 2 over 2 over 1. And this is what's really nice about having the hypotenuse be 1, is because dividing by it just kind of cancels out. So we're just left with square root of 2 over 2. I could also ask for a cosine of pi over 6. And so I'll draw out this special triangle with one of the angles being pi over 6. That's the smaller one. Remember, cosine is the adjacent side over hypotenuse. So that would be square root of 3 over 2 over 1. But dividing by 1 just goes away. So we're just left with square root of 3 over 2. And let's do one more, like tangent of pi over 3. So we'll have to label this other angle pi over 3. That's the bigger one. And remember, tangent is opposite over adjacent. So in this case, that would be square root of 3 over 2 over 1/2. So we have a fraction inside a fraction. So you just got to remember that if you divide a fraction by a fraction, that's like multiplying by its reciprocal on the bottom there. So square root of 3 over 2 times 2 over 1, the 2's cancel, and we're just left with square root of 3. So that's the tangent of pi over 3. So let's take this a step farther. We could be given an angle like negative pi over 6 and be asked to take the sine, cosine, and tangent of that angle theta, so negative pi over 6. So the first thing I'll do is draw this angle out, and remember that negative angles go clockwise. So this would be my small pi over 6 angle going down, and I'm going to turn it into a right triangle. So we'll drop a perpendicular from the x-axis to that angle, and that makes this right triangle. And this looks like that 30, 60, 90 triangle. So the small side here was 1/2, and the big side was square root of 3 over 2. Hypotenuse is 1. But since we're going down, this is going to be negative 1/2. All right, now that everything's labeled, let's take a look at finding the sine of this angle. So remember, sine is opposite over hypotenuse. And if we take a look at this angle here being theta, opposite is negative 1/2 over 1. Again, dividing by 1 doesn't really mean anything, so it's just negative 1/2. Cosine is adjacent over hypotenuse. And looking at the right triangle, the adjacent side is the square root of 3 over 2, and the hypotenuse is 1. So I'm just going to write that as square root of 3 over 2. And then tangent was opposite over adjacent. On the right triangle, the opposite side is the negative 1/2, and adjacent is square root of 3 over 2. So I'll do that work over here. It's a fraction divided by a fraction again, so I'll multiply by the reciprocal of the bottom. So the 2's cancel, and I'm left with negative 1 over the square root of 3. And we're going to rationalize the denominator again by multiplying that square root of 3 out of there. So on top we get a square root of 3, and the bottom, the square roots cancel, and we're just left with a 3. Although it should have been negative. So let's do all that again, but this time with the angle 3 pi over 4. So we're going to be finding the sine, cosine, and tangent of that angle. So to draw this out, I'm thinking of pi being at like 180 degrees, and I'm cutting that into fourths, and I want 3 pi over 4, like 3 of them. So that'd be right there. And if I make this into a right triangle, that's like my pi over 4, or like 45, 45, 90 triangle. So this is going to be square root of 2 over 2, square root of 2 over 2, and the hypotenuse is 1. But since we're going to the left, that's going to be a negative square root of 2 over 2. So here's my angle theta, and if I was taking the sine of that angle, sine is opposite over hypotenuse. So that'd be square root of 2 over 2 over 1, and I'm just going to write that as the square root of 2 over 2. Cosine is adjacent over hypotenuse, so that would be negative square root of 2 over 2. Not going to bother writing the dividing by 1. And then finally, tangent is opposite over adjacent. So it's square root of 2 over 2 over negative square root of 2 over 2. We're basically dividing the same value by itself, except for one of them is negative. So after you see this work here, you'll see it's just going to be negative 1 when everything cancels out. All right, this time we'll do theta being 13 pi over 6. So when we find the sine, cosine, and tangent of that, again, the first thing we do is to draw out this angle 13 pi over 6, which is pretty big. So I'm going to think of this being 6 pi over 6. And then 1 full time around 2 pi, that would be like 12 pi over 6. So we want just a little bit more, and that makes 13 pi over 6. So you can see this is going to be like the short and wide triangle. So the short side is going to be 1/2. The long side is square root of 3 over 2, and the hypotenuse is 1. So to find the sine of that angle theta, opposite over hypotenuse would be 1/2 over 1, which is just 1/2. Cosine is adjacent over hypotenuse. That would be square root of 3 over 2 over 1. Again, that's just square root of 3 over 2. And then tangent is opposite over adjacent. So it's going to be 1/2 over the square root of 3 over 2. So let's do that work. So that 1/2 over the square root of 3 over 2 means I'm going to be multiplying by the reciprocal. So 2 over the square root of 3. That means the 2's will cancel, and I'll be left with 1 over the square root of 3. And remember, we don't want that radical in the denominator, so we'll rationalize it by multiplying that out of the denominator. So on top, again, this is the same work we did before. 1 times the square root of 3 is just square root of 3. And when you multiply square root of 3 by itself, it's like squaring it, so the square root goes away, and we're left with just a 3. All right, our last example like this is going to be 4 pi over 3. And if I was going to draw that angle out, I'd be thinking of pi at 180 degrees. That's kind of like 3 pi over 3. So 4 pi over 3 is one more section, so that angle would be down here. So we'll make that into a right triangle, and that makes it like the tall, skinny triangle. So the top side will be 1/2, and the left side will be square root of 3 over 2. Hypotenuse is 1. Since we're going left and down, these sides will both be negative. All right, so sine of this angle, sine is opposite over hypotenuse. So that would be negative square root of 3 over 2 over 1. And again, we won't write the dividing by 1, so it's just negative square root of 3 over 2. Cosine would be adjacent over hypotenuse, so that would be negative 1/2. And tangent is opposite over adjacent. And that would be negative square root of 3 over 2 over negative 1/2. So when I multiply by the reciprocal of the bottom, that's going to have 2's canceling, and we'll also have the negatives cancel. So I'm just left with the square root of 3. All right, so now let's take our unit circle, and we'll draw it on the xy axis. So the radius here is 1, and there's my angle theta, but it makes this point on the circumference x comma y. So we'll make this into a right triangle just like we have been, and that would make this bottom side x, and the right side would be y, and that's coming from that point that we labeled generically as xy. So let's find the cosine of this angle theta, and with the hypotenuse being 1, it's just x over 1, which is just x. And sine of theta would be y over 1, and that's just y. And we could look at tangent of theta. Now tangent is opposite over adjacent, so that would be y over x. But if you think of y over x, it's kind of like slope. It's like rise over run. So tangent is actually really useful for us. So we could think of a point being like cosine comma sine. That's like the x comma y. We're going to use this fact a lot. So the x value is always the cosine and the y value is always the sine. And we could think of tangent, since it's y over x, that would be like sine of theta over cosine of theta. This is actually your first trig identity, so that's really important. We'll be using that quite a bit. Now, trigonometry is the study of right triangles, which is why we always draw our angles into triangles around the unit circle. But there's a problem if we were drawing an angle like 270 degrees or 3 pi over 2, we can't drop a perpendicular to the x-axis and make a triangle out of that. So that's why it's really useful for us to be thinking about cosine being the x value and sine being the y value, because then anytime we have these quadrant angles, they're called quadrant angles if they line up on either the x or the y axis. So we can't make right triangles out of them, but we can just think of the cosine and sine values coming from these points. Right? So like cosine of 0 degrees and sine of 0 degrees, that would be 1 comma 0, because that's where that angle 0 degrees is. If I looked at cosine of 90 degrees and sine of 90 degrees, looking up at that angle 90 degrees, well, the point up there is 0 comma 1. So cosine of 90 is 0, sine of 90 is 1. We could do the same thing for 180 degrees. Right, so over there, the cosine of the x value is negative 1, and the sine of 180 degrees is 0. And lastly, with 270 degrees, cosine is 0, and sine is negative 1. All right, the next thing we're going to do is kind of strange. We're going to take the sine, cosine, tangent, cosecant, secant, and cotangent of an angle t, and we're not even going to know what the angle is. But we know it goes to this point on the unit circle, negative 3/5, comma 4/5. And since it's the unit circle, the radius there is 1. So I'm going to change this into a right triangle and label the sides. So this x is negative 3/5 and the y distance there is 4/5. And if you don't believe that that's a point on the unit circle, you can actually plug it into the Pythagorean theorem, right? Because that should work with a right triangle. So square both legs and then that should equal 1 squared. All right, so let's see if that's true. So if I square negative 3/5, that would give me 9/25. Over here I'd get 16/25. Yep, you get 25/25, so that checks out. So all that did for us is just verify that that point is on the unit circle. So now let's take a look at sine of this angle t. So we'll use this reference triangle, and we'll say that sine is opposite over adjacent, so 4/5 over 1 is just 4/5. Cosine of t would be like negative 3/5 over 1, which I'll just write as negative 3/5, and then tangent is opposite over adjacent, so 4/5 over negative 3/5. And again, if you multiply by the reciprocal of the bottom, that would be 4/5 times negative 5 over 3, which is nice because the 5's cancel, and you're just left with negative 4 over 3. So negative 4/3. But we also have to take a look at the reciprocal trig functions. So cosecant of t is the reciprocal of sine, making this 5/4. Secant is the reciprocal of cosine, which would make this negative 5/3. And cotangent is the reciprocal of tangent, which would make this negative 3/4. So once you know the first three, the reciprocal trig functions come along really fast. To wrap up, we're just going to do a few more examples, and in this one we're going to find some point xy on the unit circle that corresponds to the angle 7 pi over 4. So think of pi being at 180 degrees, and then we can cut it into fourths, right? So that would be like 4 pi over 4 there, and then 5 pi over 4, 6 pi over 4, and then 7 pi over 4 would be this angle. And you can see it corresponds to some point xy on the unit circle. And we're going to figure out what those coordinates are. All right, so to think of what this reference angle would be, I'm going to think of one full time around the circle being 8 pi over 4. And if our angle is 7 pi over 4, that means that we have 1 pi over 4 left. All right, so that makes this like the 45, 45, 90 triangle, which means that the x value and the y values are both square root of 2 over 2. We just have to be careful about positives and negatives because the right side is going down there, so that would be negative square root of 2 over 2. And that pretty much does it for us. As long as you remember that cosine of theta is the x value and sine of theta is the y value, we just have to find cosine and sine on this right triangle. So cosine of pi over 4 is adjacent over hypotenuse, and that would just be square root of 2 over 2 over 1. Remember, the radius is 1 since we're on the unit circle. All right, so x is just square root of 2 over 2, and the sine of pi over 4 would be negative square root of 2 over 2 over 1 since we're going down, and there's the y value. The next thing we're going to do is evaluate all 6 trig functions for the angle negative pi. So the first thing to notice is since it's a negative angle, we're going to measure it clockwise, although it does put it in the same spot on the unit circle as regular pi. But this is a quadrant angle, so we can't make a right triangle out of it. We'll just think of it as having this point negative 1, 0. So if I wanted to find the sine of negative pi, remember sine is the y value, so sine of negative pi would be 0, and cosine of negative pi is the x value, that's negative 1. Remember, tangent is like sine over cosine or y over x, so that would be 0 over negative 1, which just simplifies to 0. But we do have 3 more trig functions. Remember, cosecant, that's the reciprocal of sine. So 0 you could think of as 0 over 1, and the reciprocal of that would just be 1 over 0. All right? Now 1 over 0, you can't divide by 0, so we'll just call that undefined. With secant was the reciprocal of cosine. So -1, again, you can think of that as being over 1 to make it into a fraction, and if you flip that, it would still just equal -1. The last one is cotangent, the reciprocal of tangent. So that would be, instead of 0 over -1, it's going to be -1 over 0. But again, you can't divide by 0, so cotangent of -pi is also undefined. You can't find that value. All right, let's run through another example where we'll do all 6 trig functions for the angle pi over 2 this time. So we'll take pi and cut it in half. So pi over 2 is at 90 degrees. It's a vertical line like this. And since it's vertical, we can't drop a perpendicular to make a right triangle out of it. So we'll just think of this point 0, 1. Remember, sine is the y value and cosine is the x value. So sine of pi over 2 is just 1. Cosine of pi over 2 is just 0. And tangent is sine over cosine, and that would be 1 over 0. Can't divide by 0, so tangent of pi over 2 is undefined. All right, so now let's take a look at the other 3 trig functions. Remember, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So to find cosecant, the reciprocal of 1 stays just 1. The reciprocal of 0 over 1 would be 1 over 0. And you can't divide by 0, so secant of pi over 2 is also undefined. And cotangent, that's the reciprocal of undefined, or like 1 over 0, would become 0 over 1, and that simplifies to just being 0. The last thing we're going to do is just evaluate angles that are outside of the 2 pi range of the unit circle. So like if we were asked about sine of 3 pi, well, pi is like 180 degrees, and then 2 pi is 1 full time around the circle. And then if you wanted 3 pi, that's just like another half time around the circle. So 3 pi is over here, basically the same spot as 180 degrees. So if I draw that angle, again, it's a quadrant angle, so I can't think of it as being a right triangle, but I'll think of the point -1, 0, and sine is the y value, so sine of 3 pi is just 0. The next angle we're looking at is -7 pi over 2, and we're going to find tangent of it. Since it's a negative angle, we have to measure clockwise, so negative pi over 2 is here, and this would be 1, 2, 3, 4, 5, 6, 7 pi over 2. So -7 pi over 2 is just straight up like 90 degrees. Now, it's a quadrant angle again, so I can't make a right triangle out of it, but I'll just think of the point being 0, 1. And then if I was finding tangent, that's like y over x, so 1 over 0. And again, you can't divide by 0, so this last answer is just undefined.